Hi friends, welcome back. We are designing a four-story building elevator. In our first lecture of this series, we have seen the basics, what all switches are available. So we have four floors: ground floor, first floor, second floor, third floor, called 0, 1, 2, 3 respectively. Then we have a switch to open the door. There is a switch to close the door. There is a start or stop button, and there is a button to on or off the fan. There is a button to on or off the light. All these are inside the cabin, and on each floor there are switches to get the service from the elevator. Then at every floor we have sensors which just try to tell where the car is, and there are door close sensors just confirm that the door is closed or not. So if all the four doors are closed, only then lift should be moved, otherwise it is hazardous, so we need to look at it. Then we get some input from the motor, whether the motor is on or off, and what is the current position of the elevator. Then we produce outputs like to rotate the motor such that the elevator moves up or moves down. Then the motor is turned on or off. Then output to open the door, close the door. There are four such outputs, one for each floor. That's a schematic we had seen: ground floor, first floor, second floor, third floor. These are the sensors to identify where the elevator is currently, and this is how the elevator system mechanically is built. So that's a elevator, and this is suspended to motor through a pulley arrangement. On the other end of the pulley there is a counter load, and this motor is rotated clockwise, anti-clockwise, and because of which the elevator keeps moving up and down. So that's how we started working. Then later, from the floor switches we get input. So any floor requires a service, or anybody wants service of the elevator, he will just press the floor button, and the floor request input goes high when one of the floor button is hit. Or once the person gets in, he will request where to take him. So in car switches are there, so four in car switches to go to respective floors. So that's a car request goes high when one of these is hit, or in any of the eight switches is hit, a request button or the request input will go high. When none of the inputs is available, request output will be null or zero. Then to identify where the which of the floor switch was pressed, we use a 4 to 2 encoder. So one of the four is high, others are low. So corresponding, if this is high, this will get 0 0. If this is high, we get 0 1. For this we get 1 0. For this we get 1 1. Same case here. And then depending on, this whole thing should be active only when there is some request, and the enable pin is active low, therefore we are connecting request bar here. And to which request is coming from, is it coming from floor or coming from in car? So we are giving in car request signal as a the selection line, and when this is 0, then floor inputs are connected to the output. when this is 1, then in cars which values are connected here. So depending on that, we get a where to go, whether it is because of somebody outside is requesting or somebody inside is requesting, whatever be the say, it says where the elevator should move now. So that's what we call destination. At that instant where the elevator is, that we get from the sensors which are available at each floor. So fs0, fs1, fs2, fs3, and accordingly again 2-bit encoding is done from 4 to 2 encoders, and these two are compared, and then we get three outputs where the elevator is and where it should move. If elevator is at a lower floor compared to destination, then this output will be high, and the elevator is at the floor where destination is, then we get this output high. If the elevator is at a higher position compared to destination, then this will be high. So if we get this as output, then we should make somehow move the elevator up. If it is here, then we should make sure to move the elevator down, and if it is here, we should ensure to open the door. How? Let's check out now. So let's begin our journey with our initial state. And with the initial state, if we get yes less than d, then we should move the elevator up. If we get an output input yes greater than d, then we should move it down, so we reach another state. And if you are here and if s is less than t still, then you should keep doing this. You should keep doing this as long as s is less than d, and you keep moving up. Otherwise, what you can do, another option is you can reach back, and this continues as long as they are different, and when s is equal to d, then you need to stop. So same way here, as long as s is greater than d, keep moving the elevator down, and when s becomes equal to, then you stop. So once stopped, what to do? Once the motor is off, so once the motor is off, then open door, and once door is opened, wait for some time, and then motor is still off, close door, then once the door is closed, then just back here and wait for next switch, next request, and once the next request is available, yes, this process can continue. So we can call this state A, this is B, this is C, this is D, this is E, and this is F. 1, 2, 3, 4, 5, 6. 6 states. That means some 3-bit coding is required to tell this, and then we need to create a table, and then a new type of map is used, and this can be used to design the elevator controller. So how and all we'll see in our coming sessions. So till then, take care. Bye.